welcome everyone. Welcome back to my channel. Today I'm gonna start topic which is Frustum. But before we start this topic, I'm running GCSE batch classes at just £6 per hour. It's just a micro batch, like hardly 3 or 4 students in a class. And also it's for every subject, almost every subject. I have tutors for all subjects. They are pretty experienced and very good in teaching. If you need to book a demo for GCSE classes or for any class from year 1 to year 13 for any subject, just email us at exacademy@gmail.com. So now we are starting Frustum. Frustum is basically a shape when you cut a specified shape. There are two types of frustum: frustum of cones and frustum of pyramids. In frustum of cones, we are taking a cone and then we are just slashing their head. So you can see it's a cone here, and if I cut down the upper portion, this one, and completely eliminate this, the remaining would be this. So there's no upper part, you have removed it, so remaining is now the circular part. Obviously if you cut down the upper part, now there would be only circle remaining up there, and this is your frustum of cone, and this shape is basically a frustum. If we have to calculate the surface area, because frustum is a shape which is derived from the cone, the frustum of cone is derived from cone, so we should know the formula to calculate the total surface area of a cone. So I'm just drawing a cone just by its side so that we can compare them easily. So now we can easily compare. The right side is a cone and left side is a frustum. If I want to calculate the surface area, the total surface area of a cone, I have to add the surface area of the two surfaces of this cone. Clearly, I can see there are two surface areas or two surfaces of this cone. This one, the bottom one, which is a circle, and this upper one, which is a curved surface. So it would be curved surface 2 plus bottom circle. If this be the radius, we have this vertical height here, this one, and this one be the slant height, which is L. So the curved surface area is pi r L. This is the formula to calculate the curved surface area. And the bottom one is a circle, and the area of a circle is pi r squared. So this will be L plus r. That would be the total surface area of this cone. Now you have cut down its head, the some part, the upper cone, you can say you have already cut down. The remaining part is your frustum, and because you have cut down, there are three surfaces remaining here. The bottom one, the first surface, the second, the curved one, and the third, the upper circle. This is the same radius as this one because we have cut this. So obviously the bottom will remain exactly the same. Now, because some of the part you have already cut down, so this H has changed. Now this would be H1. Obviously this L would also have changed, which would be L1. And this radius is also the different, which is R1, I would say. So this, if I'll calculate the surface area of frustum, so area of the top circle, which is pi r1 squared, pi r1 squared, plus area of the bottom one, the radius remains exactly the same r, so the area is also the same, which is pi r squared plus this curved surface remaining. Now this is a little tricky. If you understand, it's very easy, to be honest. You have cut down this part. That means this smaller is also a cone. So if I draw it here, this remaining part, this is your cone. You have just cut down, but still, if you attach this one, it will give you this cone. So if I'll calculate the total surface area of this curved part, this total, because in this cone there are two surfaces, the bottom one, the circle, and this curved surface. It was easy to calculate the area of these two circles. Now the curved surface, we have to calculate the area of the curved surface. So area of this curved surface is basically, if I want to calculate this part, so if I'll calculate the area of this whole curved part and I'll subtract the area of this one. So in short, I can clear you. I have calculated the area of this whole curved part. And out of that, I have subtracted, if I subtract the area of this curved part, because this is the smaller cone that I have cut down to make a cone, a frustum. So if I subtract it, then obviously this would be the remaining one, which is nothing but this. So what I need to do is I have to calculate the total curved part or curved surface area of the original cone, which is pi rl. So it's pi rl. And now I have to calculate this one. So we know its radius is r1, same as this one. They have the same radius. So this would be pi r1. And this part would be, let's say, L2. For this smaller cone, the radius is r1 and the slant height is L1. So this would be pi rl minus pi r1 L2. And this is how you can calculate the total surface area of this frustum. Now the question is, what if in the question they haven't given the value of R1 or L2? I mean, if any of the other part is missing. In many questions, they will give you the radius directly, but in many questions, they will not. So let me do one question in which all the data is already given. We'll start with some simpler question, then we'll move on to some harder parts. So let me see this one. Now see this question. It says find the area of the following frustum. This is our frustum. Here we can clearly see the radius. The two small radius are given as 20 centimeters and 8 centimeters, whereas the slant height of this frustum is given as 15 centimeters. Apart from that, it says it's made up from a cone, like the original cone, having the height 15 centimeters and slant height 25 centimeters. That means if I extend it up there like this, there is a cone, and this is made up of, let me just draw it a little properly, like this. So this cone has a complete slant height of 25 centimeters. If this part is 15 centimeters, obviously this remaining part would be 10 centimeters. Now, to calculate the area of frustum, we should know the slant height. So the important part is, it's not very important to calculate the other stuff. Obviously, I mean, we don't need the vertical height or anything in this question. Only the slant height is more than enough. Why? Because for this frustum, we have three surface areas. This one would be the 1, 2, and 3. Surface area of all together, we have to basically add. So area of the first one is pi r squared, which is pi 8 squared. For this one, r is 8 centimeters, so pi 8 squared plus, now we have to calculate this curved part, which I told you, you first have to calculate the curved surface of cone minus curved surface of smaller cone plus pi r squared, that means area of the bottom one, which is pi times 20 squared. So this will give you 64 pi plus curved surface area of the cone, we know pi r L, this one. So for bigger one, the slant height is 25 centimeters. So pi radius, obviously I have to take this one, which is 20. So pi times 20 plus L, which is 25, minus curved surface area of this smaller part, which is this smaller cone has radius 8 centimeters and slant height as 10 centimeters. So it would be pi times 10 times 8. So now we have calculated the area of the bottom circle, which is pi times 20 squared, that is 400 pi. The upper one, the smaller one, which is pi times 8 squared, that is 64 pi. And we have subtracted the curved part of the bigger cone and small cone, and it gave us 500 pi minus 80 pi. That will give you 884 pi. If it's a non-calculator paper or it's written that give your answer in pi's only, then your answer would be 884 pi. But if it's a calculator paper or they have mentioned that up to 2 decimal places, definitely that would be given in the calculator paper. Then you have to put the value of pi and we'll get the answer as 2775.76 centimeters squared. So this is how you can calculate the total surface area of a frustum. Well, in this question, already the radius were given, right? Both the radius were given, the slant height was given. So all we need to do was just to put the values. But what if one value would be missing in this case? Then we have to keep in mind one important thing, that is that the cone that you have slashed, basically that you have dissected, that smaller cone, that is that the upper part of this, the smaller cone and the bigger cone from which you have made the frustum, they all, like they both are similar figure. Let's see this one. See, this is the actual cone, and then you have cut down the top part, and once you cut down the top part, it becomes this, that is the frustum. So this is how we have shown this one. I mean, when you cut down the upper part of the cone, the smaller cone, then you will get a frustum. So the cone has two parts, this upper part, the smaller cone, and the bottom one is your frustum. So this smaller cone and this bigger cone, they both are actually parallel, obviously. I mean, it's a part of it. They always are similar figure because they have the same angles, obviously, and then their ratios, their corresponding sides are always in ratio, so they are similar figures. And this is how we can calculate the missing radius or any missing parameter. See, I can say if these two are similar. Which two? This is smaller and this bigger cone. So the corresponding sides will be in ratio. That means this L3 over L2 is equals to H3 over H1. Sorry, this is L1. So L3 over L1, because corresponding sides both should be slant height. Now I can divide the vertical height. So H3 over H1, and now the corresponding radius. So R2 over R1. So you can use these ratios to find the missing side. So let me do one question regarding it. See this question. This question says find the total surface area of the following frustum if the slant height of the cone was 26 centimeters. And this is the cone given. The radius of, the frustum given, the radius of this is 10 centimeters, which is same as the radius of a cone. 16 centimeter is the slant height of this frustum, whereas the slant height of the frustum, the cone is 26 centimeters. That means if I extend this and make a cone, the total slant height would be 26 centimeters. Now you have to calculate the total surface area. We just did, and we know to calculate the total surface area, we should know this radius. This is very important, and unfortunately that is not given in this question. But we do have some other information given. So this frustum is a part of the bigger cone, which looks like this. This cone has total slant height as 26 centimeters and radius as 10 centimeters. I can clearly see that the smaller cone will be having a slant height of 26 minus 16 because this is 26, and when I took away the upper part, the lower part is 16 centimeters, which means this part is 10 centimeters. Now we have to calculate this radius. So we have to apply that this smaller cone and this larger cone are similar figures. So I have to divide the corresponding sides, which is 26 over 10. Slant height of the bigger cone over slant height of the smaller cone is equals to radius of the bigger cone over x. So from here, I'll get x is equals to 100 over 26 centimeters, which is approximately equals to 3.85 centimeters. So because of this, the one that I have discussed, that if you don't know a given parameter, you just have to use the similarity and you can calculate. We now have the radius, which is 3.85 centimeters. We can easily calculate the total surface area. How we can calculate? Similarly, how we did our first question. That means I have to calculate the area of the upper part. Area of the upper part is pi r squared. So pi times 3.85 whole squared plus area of the bottom part, which is pi times 10 squared. So pi times 10 squared plus this third curved part. So curved part is, I have to calculate the area of the curved part of the bigger cone and I have to subtract the smaller cone. In this way, I'll get the curved part of this frustum. So plus area of the bigger cone is, we know the slant height is 26 centimeters, so it will be pi times 26 times r, which is 10, minus, for this is smaller one, we just saw that the slant height is 10 because this is 26, this is given as 16, so obviously this is going to be 10. 26 minus 16, so it would be pi times 10 times this radius, because we are calculating the curved part of this smaller cone now. So smaller cone has a slant height 10 and radius as 3.85. If you solve all of these together, you will get the total surface area of this frustum. So you can clearly see I have written that this is the area of the upper circle, this one for 14.82 pi. 100 pi is the area of this bottom circle, and 221.5 is the area of the curved part, which will give you 336.32 pi. This answer is in terms of pi. If we'll multiply the pi, we'll get the answer as 10560.04 centimeters squared. So this would be your final answer. So this is how you can calculate the missing parameter. Now, if we have to calculate the volume of the frustum, how we can calculate? So volume part is pretty easy because volume is always the sum. That means suppose this is a figure, any figure. This is a sphere you can see. If I make 4 equal parts, so the volume of each part, if I add them up, will give me the volume of this whole sphere. In case of total surface area, it doesn't work like that because it all depends on your surfaces, how many surfaces a particular object has, and accordingly you can calculate. So the most common mistake a student does is they think that if they will add the surface area of each figure, they will get the total surface area, which means suppose it's mentioned that there are 4 small spheres or 4 small cubes. The surface area of each cube is 20, suppose. If you join all of them together, what will be the surface area of the resultant cube? In that case, what they do, they just add them up. It doesn't work like that. But in case of volume, it would. That means if it's written that 20 centimeter cube is the volume of small cube and there are 4 such cubes, if you join them together, you will get a bigger cube. What will be the volume of it? In that case, yeah, if you add them up, you will get the volume of the bigger cube. Same thing we have to apply here. We know that when we cut down the cone into 2 parts, that means the upper cone, if you remove the upper cone, you will get a frustum. So if you want to calculate the volume of a frustum, you have to just calculate the total volume of this cone and subtract the volume of this smaller cone, you will get the volume of the frustum. So this thing happens only in the case of volume. So we know that the volume of a cone is 1/3 pi r squared h. This is always 1/3 the volume of the cylinder having the same radius and height. So volume of this cone is 1/3 pi r1 squared h1. And volume of this smaller cone is 1/3 pi r2 squared h3. And I just need to subtract them. This will give me the volume of the frustum. So now let me do one question on the same. Here I have already written that the volume of frustum is 1/3 pi r1 squared h1 minus 1/3 pi r2 squared h3. Let me see this question. This question says calculate the volume of the following frustum if it's a part of a cone with height 24 centimeters, which means this frustum is a part of the bigger cone. And this cone has a vertical height of 24 centimeters, which means the smaller cone that we have already cut down, the height of that would be 24 minus 12. This is the height of the bigger cone. You have subtracted a smaller cone out of it, and the remaining part is your frustum, which has a height of 12 centimeters. That means obviously the height of this would be 24 minus 12, which is 12 centimeters. And radius is already given. So I have to calculate the volume of the bigger cone and subtract the volume of smaller cone. So volume of bigger cone is 1/3 pi times r, which is 7 centimeters squared, times h, which is 24. Subtract the volume of the smaller cone. So smaller cone is 1/3 pi times r squared, which is 3.5 whole squared, times height, which is 12. If you subtract the volume of these, you will get the volume of frustum. So here I have written that the volume of bigger is 1 over 3 pi 7 squared times 24, and smaller is 1 over 3 pi 3.5 whole squared times 12, which is 1230.88 minus 153.86, and final answer is 1077.02 centimeter squared. So basically that's your final answer. So that's it for today. We'll be doing the worksheet on the frustum of cone, and then we'll start the frustum of pyramids, where I'll be discussing how to calculate the volume and surface area of the pyramid as well. So that's it for today. Again, if you want to access the free worksheets, you can just visit www.akziacademy.com. And if you need classes from year 1 to year 13 for any subject, you can just email us at exacademy@gmail.com to book your free slot for demo. Okay, so that's it for today. Have a great day. Bye.